Hello everyone, welcome back to Mathtivities. Today we're going to be covering 2D motion. 2D motion is an important concept in physics, higher physics, early physics. And 2D motion essentially means when you have a projectile. It's also known as projectile motion. Now, 2D motion, describes a particle's position. Let's say, you have a cliff here, and you have a guy, and he's kicking a ball. Whoosh! He's kicking a ball. Well, instead of trying to find an equation for exactly how the particle travels or how our projectile travels, what we can try to say is we're going to try to find an equation of how the particle or projectile travels in the x position versus the y position. Now, let's say this is a graph, right? Let's say we have the ball's motion as a graph. Let's say it looks like this. And this will be position in meters, and this will be time. Now, this is the x position. Okay, this means how the ball travels horizontally. And if you kick a ball, usually when you kick something, right, you're going to want to draw a force diagram. So let's draw a force diagram over here. So when we kick a ball, let's say we kick it upward. Okay, so we're going to have this force, our force kick. It's going to be a force kick. And this is only going to be at one point, right? You kick the ball, you stop kicking it, you're done. So this is going to be when you come in contact with the ball, right? But now, when the ball's in the air, okay, what's the force acting on it? Right, well, we have gravity, right? It's in the air, so we're going to write down here, right, gravity. And, well, we've stopped kicking the ball, so we're no longer applying a force. So why is the ball still moving, away from us, even though gravity is the only thing acting on it? Well, remember when you kick a ball and it travels, it has a velocity initial. So when we have that, right, let's draw two graphs. Let's draw. It's going to be our y position. It's going to be time. When we draw these graphs, our velocity here, right, in the x position, I guess we'll come back to that, what it looks like. Let's say the ball is traveling this way, right? Travels this way, your initial kick. Well, 2D motion deals with vectors. And I'm sure you've learned about vectors. They're very important in physics. And what a vector means is how something travels like a force. Like if I push something and it goes in a direction, that's a vector. It's a direction vector. That's just what they're called. So when you kick something, let's say you kick it this way. Well, the vectors, when you add vectors and you add head to tail, right? This is a head, this is a tail. You can say that they go this way, right? The total vector, the total force, right, goes this way. It's a bit tricky, but essentially just means that if you add vectors, right, the start point and the end point is your final vector. Right. Okay. Start point and the end point is your final vector. So when you have 2D motion, it's essentially describing these vectors. Right? If gravity is the only thing acting on the ball, then the gravity vector is going to be pointing downward. Right? It's going to be pointing downward, like on the force diagram. This is an arrow. So what we're doing is we're splitting up the ball's velocity in the x horizontal way and the y vertical way. Well, if gravity is the only force acting on the ball, then what is the horizontal component of this, right? This is going perfectly downward. So a horizontal component, like if we had a force here, going this way, right, we split it up into these vectors. This little thing down here, these are components, right? Because if we add these up, that will give us this total thing. But not like, you can't add the values directly, but if you added the vectors, it would. So if this x component is 0, right, as it is here, then we could say that the force is only acting on our y velocity. So if we have these velocities, we can treat them as separate. So if our initial x velocity is not touched by gravity, that means it's constant. This is our x velocity. But our y velocity, let's say it starts up here, is going to be velocity naught. Remember, it has gravity afflicting it. Gravity is an accelerating force. So our y velocity is going to go downward. If you take a ball and you kick it, and someone kicks the ball this way, it goes like this. If you notice, the velocity in this direction, x-wise, will always be constant. Right, I guess more like this way. If there's no other accelerating force acting on it. And that's sort of the basics of it. And the way that you calculate this type of stuff is through kinematic equations. Now, we covered kinematic equations in an earlier video, so make sure to go check that out. Again, this gets a bit confusing, but it's okay. Now, remember that we covered the denotion of a kinematic equation. Like velocity x is equal to velocity x naught plus acceleration x times time. Remember what I said? That these little denotions here just mention the direction. That is for 2D projectiles. So you can also say that this is just velocity y. The kinematic equations are constant throughout all your stuff. If, you only have one acting force on it. You can exchange these. Oops, it's not supposed to be an x, it's supposed to be y. You can exchange these for your velocity in the y direction, your velocity in the x direction. It's all the same here. You can pretty much just plug it in. So if you need to solve for your final y position, go ahead. You can solve it with your kinematic equations. Right? Let's think a little bit here. So if you also have these equations that tell you your different positions, well, you can use them to find each other. So let's say this guy kicks a ball, I don't know, from here. Right? Well, if the ball's horizontal component is constant, that means it's not decreasing or increasing, it's a constant. So the ball theoretically should go on forever. But it's not, because we also have this vertical component pulling us down. That's gravity, right? So the ball will go this way. Gravity is the accelerating force. It'll more likely go this way. Okay. Well, if we want to solve for when the position the ball hits the ground at, let's denote this at height 0, this little point here. Well, using our kinematic equations, all we need to technically do is solve for when the ball's height is equal to 0. For instance, say land 0 here. Because when the ball's height equals to 0, the ball will stop moving, it hits the ground, which means that we'll be able to find this horizontal distance the ball moved. Okay. So let's take a look at our kinematic equations for this. So let's say we have time, and we have gravity, our acceleration, and we have our velocity initial. So let's say velocity initials, we kick the ball at 22 meters per second. Okay, 22 meters per second. Right. So, with our equation, x is equal to x naught plus vx naught t plus ax t squared 1/2. Okay. Right. Well, how do we find the vertical and horizontal component of our ball? Well, the horizontal component is going to stay constant. And when you want to find the horizontal component, you can take this number and see what the fraction is. So 22 is equal, well, to 22 over 1. I know it seems dumb, but this is essentially our fraction. So the ball is going upward this way 22 meters. 22 meters tall per 1 meter wide. Okay, so that's essentially our initial velocity here. Now, we can plug this in. Let's say our equation, we had our ball, and we're solving for the horizontal component of our ball, right? Its horizontal position. Well, our initial horizontal position, if we denote the hillside cliff here as 0, right, this point is 0, well, we can set this equal to 0. So we can say our ball's horizontal final position is equal to 0 plus our velocity initial. Now, technically, right, it's velocity in the x direction. Oops, 1/2 a times squared. Times squared. Okay, well, we need to find the time now, right? Because, right, we need to find the time. Now, if we are solving in the x position, remember that the only accelerating force on our ball is gravity. And gravity is not any way horizontal in this example. So we can say that the horizontal component, the horizontal x component in our ball is 0. So this whole equation will be 0. So we're going to replace this with the 0. So now we have our velocity in the x position times time. Well, our velocity, as we said earlier, is just going to be 1. Right, if it's going 20 meters high per second, right, then we can say that the ball's horizontal component is just 1 times time. So there's going to be time here. Now, how do we solve for time? Well, right, we're going to leave this equation off to the side. Now, what we can do here is we can rewrite this equation as our y height. Remember, we said that we can replace all the variables with our y height for these types of equations. And what we need to do is solve for time. So we can just plug stuff in. Well, if we have our ball height here, we got this cliff. Let's say this is 10 meters up, right? Usually in problems, I'll say it's some amount. So we can say that our y position is equal to 10 plus our velocity initial. Now we had 22 meters per second here. So remember, if our denominator is 1 and our numerator must be 22. So the vertical component of our velocity is going to be 22. That will be our initial, right? Right as you kick the ball, it goes 22 meters per second. So it's going to be 22. It's going to be 22 times time. Now, we need to add 1/2 acceleration in the y direction times time squared. Okay. Well, acceleration in the y direction is gravity, right? That's the only thing affecting the ball. So we can rewrite this as negative. I guess because it's plus, it's a negative, so it's going to be minus 9.8 divided by 2 times time squared, right? 1/2 times 9.8. Now, all we need to do is solve for time. So, to do that, right? Well, I guess technically we've got one more thing to do, right? We know that when the ball hits the ground that time, the ball's height will have to be 0, right? Because it's going to be here, because that's where we're solving for. So we can set this equal to 0. And say finally, right, all we need to do is solve for t. So we can move the negative 10 over to this side. And now, right, we can just say, I guess we don't need to move the negative 10. It's just a quadratic. This is just a quadratic equation. We got negative 9.8 divided by 2, which is roughly 4.5, 4.9. So negative 4.9 t squared plus 22t plus 10 is equal to 0. And all you need to do is solve for your t variable. And once you have your t variable, we noted that the x's position over here is just going to be equal to time because there's no other force acting on it. And we solved and simplified our equation to find that the velocity in the x direction was just 1 meter per second. So velocity times time, that will give us position. So velocity is 1, and our time is going to be whatever the answer is to the quadratic equation here. So it's just going to equal the time. So now once you've found and solved for time, you can plug it in, and that will give you, when your final x position, how far it will be. Okay, that's all. Thank you so much, everyone. I hope you have a wonderful night. Make sure to like, subscribe. Please give any comments you have, any issues, any concerns. I'll try to make videos in the future. And have a good night.